Hello and welcome to this PV Tech Talk webinar in conjunction with Tongwei Solar. The title of this webinar is How Tongwei Solar's shingled modules can boost power output and reliability. My name is Sean Roach and I'll be your host for today's webinar. Joining me is Gang Shi, CTO of Tongwei's module business, Halil Demirdar, Chairman of Smart Solar Technology, and Roger Miao, General Manager of TV Nord China Renewable. In the first part of this presentation, Gang will provide a company overview of Tongwei and take a closer look at its shingled cell technology. Following that, Halil will introduce smart solar technology and his use of shingled modules. And then after that, Roger will explore industry trends and cell technology. But before we start, a bit of housekeeping on my end. Today's webinar is to last around 1 hour, including opportunities for audience questions. You can use the dialog box on your screen to submit those questions. The webinar is also being recorded and will be available on demand via PV Tech shortly. But without any further ado, I'd like to hand over to our first speaker, Gang.
Thank you, Sean. Good morning, good afternoon, good evening. My name is Gang Shi. I would like to share with you information regarding Tongwei as our company, as Tongwei's shingle module, and how it can boost the power output and reliability. So first of all, who are we? Tongwei is a company with 40 years of history. Actually, we celebrate our 40-year anniversary last month. Currently, the company has 300 branches, and we have 50,000 employees. Currently, the company is focusing on agriculture as well as renewable energy. As you can see on the slides, and the upper portion describe our agriculture, mostly fish food industry. The second line is our renewable energy, mostly the photovoltaic supply chain. As of now, Tongwei entered the renewable energy in 2006, starting with polysilicon. And as of now, we have a fully integrated industry chain. On upstream, we have our polysilicon facility, Yongxiang Group. Currently, the annual capacity is about 230,000 tons and quickly expanding. We are currently the #1 producer of polysilicon in the world. On the midstream, we have the largest cell capacity as well, currently sitting at 54 gigawatt. And we'll quickly expand to somewhere between 130 and 150 in a time frame of 2024 and 2026. On the module part, we're slightly smaller. We have about 15 gigawatt of capacity, mostly consist of the high efficiency shingle module capacity. We also have our fishery plus PV power plant. We have constructed many of those power plants in China. So what about the shingle module? What about the shingle technology? If we're looking at the mainstream technology, which is a half-cut module, we show that on these slides. On the left, the most distinctive characteristic is each of the cell, a half cell, one cell cut into half. And you can see a mirror image from the upper portion and lower portion. We're going to talk about this internal circuit just in a little bit. More importantly, the way the cell connected together is showing on the right. So in order to connect two cells in theory, with the positive side on the back of the cell and negative side on the front of the cell, the metal ribbon was used to solder from front of the first cell to the back of the second cell. So the cells are connecting in theory in this way. In comparison, the shingle module was constructed a little differently. First of all, we'll cut the full cell into smaller segments, 5, 6, or 7. Then we overlay the cell segments at the edge. So the back side of the first cell will be touching the front side of the next cell. And we use adhesive to connect the cells together. So as the positive side, a positive of the first cell is in direct connection with the negative side of the second cell, the cells are effectively connecting stereo as well. Then repeating this process, we can build a cell string. And on the right side, we show a picture of the shingle module. So you can see 6 cell strings are connecting parallel in this particular module. So compare these two processes. One is soldering, one is using adhesive to glue the cells together. One of the distinctive differences is the process temperature is different. So in the soldering process, it can get up to 220 degrees or above. And as it cools down to the room temperature where the module will be used, there's quite a bit of temperature gap. And as the the solder solidify and cool down to room temperature, quite a bit of stress is left behind in the rigid cell and the metal wires. So as you can see in the microscopic picture shown on the left, there's a risk of creating micro cracks in a structure. In comparison, the shingle module was, the process is lower temperature, 180 degree or so. And after the system is cooled down, the thermal stress created during the process can be absorbed by the adhesive. So there's much lower risk of creating any micro crack within the structure. When the structure is under load, for the flexible interconnect in the shingle module, when the system is under load, again, the flexible adhesive can take much of the stress. When the load is removed, nothing bad happen. But for a conventional module, when the system is under stress, there could be a pressure point, especially when the metal wire is in contact with the solar cell at edge, and quite often it could cause some damage or cause the already existing micro cracks to expand. And in the long term, that will be a problem, for the reliability of the module. Now thinking about when the module is under the maximum load, either under very strong wind or under very heavy snow load. And quite often, especially for the case of a snow load, it's the module is under very low temperature. That's why we're testing our module in low temperature as well. So two charts are showing here. On the left side, we do the dynamic mechanical load test on the module at minus 40 degrees with 5,000, 1,000, 2,000 cycles. The module hold up very well. And the right side, we do the static mechanical load, which is a conventional mechanical load testing. We put weight in the front and the back. The different thing we're doing here is at minus 20 degree and minus 40 degree. So as the orange bar showing is the shingle module. So with these two conditions and at different load in front and back, the module hold up very well. But the conventional half-cut module in its test, didn't hold up very well, especially at minus 40 degree. We suspect the micro crack is bent quite a bit and cause a damage and resulting to much degraded power output. We also do conventional IC test on our modules, so but also expand that to 2 times IEC, 3 times IEC, DMP, and thermal cycling. As you can see on the left side, the module hold up very well. And the module also gone through a more stringent combination of the test sequence, IEC 63209 test. And they're basically different combination of the thermal, thermal cycle, DMP, UV, and so forth. They hold up well as well. So our module obviously passed through different tests and obtained the certification for different region. Now I'd like to switch to the topic our customer asked quite a bit. First of all, is the hotspot. So hotspot is a phenomenon occur on the module. It could caused by severe shading or there's damage within the module. So what happened in that scenario is the energy the solar panel is generating, the current the panel, the cells is generating is feed into those defect area, concentrate and cause a high temperature. So it is a severe risk, especially when the cells getting bigger, the current running through the cell string is higher, then the energy can be concentrated to the defect spot is higher. Then higher temperature can cause severe damage to the solar panel. So compare the structure of a shingle module with a conventional module. Besides for cutting the cell into smaller pieces and glue them together, the direct result of that is on each of the cell string, the current is much lower. So on the left chart, we show a comparison of how much current is running through the cell string within a 182 half-cut module, a 210 millimeter half-cut module, and our 210 but shingle module. So the cell is smaller, as I mentioned before, maybe just 1/6 or 1/7 of the full size 210 cell. So the current in that particular cell string is only 1/3 of a half-cut module compared with the 210 cell. So the current is smaller. The energy can fit into defect area and cause the hotspot. The temperature will be much lower. In addition, as we're cutting the cell in smaller pieces, so the distribution of the current of each of the cell is actually distribution is narrower. The third aspect of that is even if a cell because of a mismatch or hotspot, cause a higher temperature region within the module, because the cells are in direct contact with each other, so the heat can dissipate easier to the neighboring region, cause the temperature, to be more even. So all in all, the shingle module can, even there's a hotspot, happen, and the temperature within the shingle module is much lower than say it's comparing with a half-cut module being 210 or 182. On the left chart, one of the distinctive line we draw in the middle around 126 degree is some of the backsheet how much temperature it can take. So obviously for the shingle module, even the hotspot occur is still in the safe region compared with half-cut module. Another aspect many of our customers ask about is shading. So when the installation is happened, say, with nearby object, so being a rooftop, you have chimneys, trees, other object in a way, those objects can cast a shadow on the module. So how the module perform is not how well it performs. It's not only like when there's direct sunlight. It's also matter how they perform under the shade. Because of the way the shingle module is constructed, the internal circuit is quite different. So on this page, we show 3 diagrams. The very left one is a diagram of a full cell module. So very simply, the current will flow through the module in a fully serial fashion. So all the cells are connecting serially. And in the middle, that's a half-cut module, which basically is, mirror image of, the full cell module in the upper portion, the lower portion. This is a mirror image. On the right side is a shingle module circuit. We mentioned about that earlier. So that's a 6-cell string connecting parallel. So how that performs differently under shade? Let's just imagine, 3 modules in front of us and the shading coming from the bottom. That's one of the normal case when you have row-to-row shadings, the shade will come from the bottom. So for a full cell module, because all the cells are connecting serially, if we start covering the very, very first row at the bottom, so the current will be cut off for the full module. So 100% lost. For the half-cut module, things are a little better because the mirror image in upper portion, lower portion. So even the bottom portion is cut off, we still have 1/2 of the current running through. For the shingle module, we did enjoy here for the simplicity, but it was actually separated into 3 portions. So upper, middle, and lower portion. Each was, has a bypass diode to connect in parallel with this portion. So when the very bottom of the module is shaded, we start to lose 1/3, not 1/2, not full, but only 1/3 of the current. 1/3 of the voltage is lost. So the loss is much less compared with other 2 cases. Now consider we're mounting the module in a landscape fashion. So equivalently, just like we started shading the module, say from the left. So for the full cell module, due to its internal construction, we probably lose 1/3 of its voltage. Same goes with a half-cut. But for the shingle module, because the 6-cell string are connecting parallel, when we start shading from the left, we only lost 1/6 of the full current in that case. So if we're looking at how the module performed, the output versus the percentage of the shading, that's showing on the right side. So with shingle module, the portion lost due to shading is much more gradual compared with half-cut module. So that's one of the benefits for applications. There's shading in the morning, afternoon, or due to the surrounding objects. So we have do some long-term power output tracking of our system outside. This is one of examples. So you can see for the past 2+ years in this particular installation, the shingle module actually performed quite a bit, quite well compared with half-cut module. We have done some calculation for installations in different locations. So this page is showing 660-watt Tongwei shingle module compared with 182 half-cut module power rate at 545. So the saving coming from a bigger module, and I mean basically in a string you can connect higher power output of the module. And turns out the system BOS, the balance of system cost, is lower by 3.6%, and accordingly the LCOE is lower as well. Another calculation is now we do at mid-latitude region. So because of the row-to-row distance need to be increased to reduce the effect of shading. In this particular case, the system BOS cost is reduced by 5.1%, and LCOE is reduced by 2.1%. Another benefit of the shingle module, it's actually quite obvious, is that its appearance. So in the way we're constructing the cell string, no metal tapping ribbon is used. So there's no metal wires in the front of the module when you look at it. So when the module is stored in an area like, people can actually see them, the module looks very nice, especially for residential or distributed generation. When people really care about the appearance, shingle module does stand out. The third portion, let's go through some of the offering with our shingle module line. We have what we call the 5E, which is a smaller module, and the left one on this page. So rated at the 430 watt. We have 5C, 550 watt, and also the big one, the big boy, the S6, rated at 660 watt. So with this full line of product, we hope to help our customers with their projects, either with rooftop, represented by the 5E family. We also have a even smaller one, 5K, to meet the requirement for the European markets when in some country or regions, the module cannot exceed 2 meters square in size. So we have a 5K with, I believe it's 420 watt or so. So with this full line of offering, we hope to serve our customers in residential, CNI, as well as large-scale ground mount projects. And a product roadmap. So we mentioned the 5K, 5E, 5C, S6. By the way, the 5C, we also both have the bifacial version or as the glass backship version. So our customer can choose that. In this one, we also show the 210 N type. So that's the one. It's still under develop, so it's not mass producing right now. But hopefully, by next year, we can start offering to our customer. Some project example, some ground mount solar project, as you can see here, mostly in China as of now, and the distributed projects being on the rooftop, being on the residential. So we've been selling those products, especially in the European market, and our customers really like them. Our footprint around the globe, and that's the part for the shingle module from our side. So now I would like to hand it to our friends at Smart Energy, Halil, and you can take over.
Thank you, dear Gang. This is Halil Demirda from Smart Solar Technologies. I am the founder and CEO of Smart Solar Technologies. I would like to give you some information about us. We started our business in 2009 in solar business in East Europe, and we grew our company mainly in Europe countries. And today we are in almost all Europe, making EPC and module sales. Our company started to produce modules in 2016, investment in 2017. We started our first factory in Turkey. We have now the second factory, and the third one is under construction also in Turkey. We are also planning to make a cell factory in Turkey, and we are working closely with a partner as Tongwei, and also they're one of their biggest partners, CND. With whom we are also planning to develop good projects with shingle products in Europe as well. Our company has, as I told you, cell production by next year. We have at the moment PV production about 1,500 megawatts. So we have EPC services in all Europe, and we have our own investments. That makes a difference. That we do invest first in the technologies that we trust, and then we offer it to the other investors. And we have our more than 100 megawatt of solar power plants working around Europe. In our PV manufacturing, we have more than 600 people, 1,500 megawatt of capacity, and a land of 31,000 square meters with 95% of automation. Our company was announced fastest growing technology company in Turkey, one of them by Deloitte. We were among the 100 fastest growing companies in Turkey. And here is our minister and the president of the business association giving the award to our general manager, Mr. Hakan Akkoç. Some projects from Turkey, we have clients with tens of megawatts of projects in Turkey. I would like to talk about the advantages of a better system than the other system. First of all, we are talking about carbon emissions. And if we are talking about carbon emissions, the carbon emission of a module is also very important. So a more efficient module means less carbon emissions also in the production. And after the production, after establishing the power plant, if your power plant is producing more electricity out of the module, it means that you are also helping and you are creating more green certificates for your investor. As you know, carbon footprint is becoming more and more important in all the world, especially in Europe. Every product will be taxed by carbon tax. So this is a near future, and in the near future, all the investors will be caring about producing more green certificates, so less carbon emissions, and they will make money also from the carbon footprint cleaning by green certificates. So we will produce electricity, and also we will be selling green certificates as investors. That's why when we design a system, we have to choose the most effective products. About shingle, actually, Gang explained very well. I will not go into the same details and not to make you more listen the same things. All these are the things that already explained. Here we have the ECA, which means higher power in the same square meter. We have a large active cell area. Lower hotspot is most important thing for me, because after we do this EPC, we are in the field again, in front of the customer, in front of the investor, in front of the house owner. And one of the biggest problems, according to all kind of statistics, is the modules has a lot of hotspot problems. To decrease the hotspot is one of the most important things in the future of a power plant, a solar power plant. This will help us a lot as installers, as EPC companies, to have less problems, and we believe that the hotspot problem will be solved better by shingle modules. This was also explained that there are more ways that the current can flow with some, let's say, as a leaf or some dirt comes to the module, and this module will work better thanks to the shingle design. Also on the other side, if you look to the module, you will see that we have two different way of cabling in the module itself. So if we want to make a portrait installation or a landscape installation or a tracking system installation, we can order our shingle module based on what we need. And then if we do the cabling in a way that we can decrease the cables too much. I have seen projects where we have the cables of the junction box more than 1.2 meters even. This means that every module in two sides, plus and minus 2.4 meters of cable length, that is increasing the losses in your power plant more than any other plant. So to keep these cables short will be also helping a lot to the power plant for levelized cost of electricity and also installation cost, and also the module cost will be less because you will buy a module with a shorter cable and the module producer will reflect this price advantage to you. There are different calculations as you see before the first presentation. Also, we think that levelized cost of electricity is reduced more than 1.5%, and the balance of the system cost is reduced more than 3.6%. So we increase the efficiency, we have a better aesthetics. In big EPC, maybe nobody cares about the aesthetics, but especially decreasing the lead here. Also, I believe that it will be a cost-effective production for modules. So I believe that in long term, also the shingle modules increasing the power, decreasing the lead and the copper as well, because you don't have these ribbons in these modules. And as we all know, ribbon produced from copper, and the copper prices are increasing, and there are a lot of expectations that it will increase a lot because of the car industry, especially the battery industry. So here we may also have future advantages. We believe that there will be some future advantages with these products. This is one of our power plants that is a unique power plant where we did use bifacial and tracking system, where we have seen how important it is for the investor to use these new technologies. Every single change that you do in the technology and every single little efficiency increase can bring you a lot of money, when especially you are talking about big projects like 50, 150 megawatt projects. Any single optimization is making it so much better. Also, there's a good bifaciality in shingle modules, and shingle modules with bifacial effect with tracking system would create an incredible production. Here, as you see, we have written 2,110 kilowatt hour per kilowatt peak yearly specific production. And Turkey, yes, is a good irradiation area, but this is almost 10% more than the expected production. And this is showing how important it is to choose the products that you are using in EPC. There are different kind of connections. I will not go into those technical sides as my colleagues are too technical, and Fraunhofer has also a lot of things about this shingle products. And hopefully we will be establishing, installing these products, establishing a stronger relation with Tongwei and also with CND, and installing these products through our offices in Germany, Bulgaria, Switzerland, Romania, Turkey, Ukraine, Greece, and hopefully we will be also in the other side of the continent. We will be in the United States next year. And we believe that we will be able to produce also these modules in Turkey and to ship them out to overseas as well. Thank you very much. And now I would like to give the floor to Roger.
Thank you, Halil. Hello, everyone. This is Roger from TIP North China. Today, my topic is reliability evaluation of N-type high-efficiency PV module. My presentation includes 4 parts. First, let's go to the first one. As we all know, the price of module declined by more than 99% since 1976 due to mass-scale production and the dramatic decline in cost of raw materials. However, the trend of continuous and rapid decline of the cost in PV project has slowed down since 2012. See the right picture, this is because the rising price of raw materials and the related energy consumption. So the affordable access to the grid cannot be realized merely depend on the cost cutting of raw materials. This is the equation for LCOE calculation. Obviously, there are two ways to lower LCOE: increase energy generation in the denominator part or decrease the capital in numerator part. In other words, the hands of life cycle generation is considered to be an effective way to lower the cost of kilowatt hours. Also, LCOE can be significantly reduced by improving the efficiency of PV module, optimizing the temperature and the load reading performance, as well as extending the life cycle of PV system. So from the side of PV manufacturer, select the high efficiency solar cell roadmap and generate more energy with its lifetime if achievable. So second, I would like to have a brief introduction of N-type module with larger size. After years of development, solar cell with PERC technology has approached to its theoretical efficiency limit. N-type module is considered to be a preferable technology roadmap in future for its property with high efficiency, better bifacial output, lower temperature coefficiency, lower LID performance, and thinner wafer. So PV module with 182mm and 210mm solar cell represent for the typical large size PV module. We can see from table that both the module size and electrical parameters such as ISC increase dramatically comparing with the conventional PV module. However, this emerging technology may bring advantages such as higher power output, also the risk to a PV module, for example, larger dimension. So the risk analysis and reliable evaluation is very necessary. So let's go to this part. In order to make a evaluation, we have different categories of tests based on IEC standards, include testing of electrical property and mechanical property. First, let's have a look at the power measurement for high efficiency module. Our lab have used several different test methods on N-type. The result of the power test for N-type module varies by different test methods. The gap is around 13% with 36 watt difference. You can see in this picture. This is a very amazing value. For hysteresis effect exists in N-type module during the IV measurement, which can introduce a significant error in measurement results. So by analyzing the result of measurement applied by different methods, we found that multi-flash and dragon-back methods are basically consistent with those of long pulsar simulator. So according to our lab testing experience, short pulsar simulator is not suitable for high efficiency module. When you test this means when you test a module, use the one-time flash with the short pulsar is not suitable. So from the last slide, we know the different measurement methods have different output value, and we all know for the temperature coefficient of the N-type module have the good values. You can see from these three pictures. The first one, we cool the module from 55 to 25 degrees, but the value is at minus 0.364%. And in middle, we have the value at minus 0.302%. When we use the temperature control box and the high accuracy test measurement methods with the result of 0.259%. So these three values have big difference. So from our experience, we recommend to perform the temperature coefficient, use the temperature control box and long parcel simulator as well. Also, in order to evaluate the LETID and the LID effects, we have set up a experience for the PERC and the N-type module. We found that N-type module show nearly zero degradation after multiple round of tests in both LID and LETID. This is an extended stress test comparison for N-type module with double glass and single glass. Damped 3000 thermocycling 600 triple stress compared with basic IEC standard requirements. The result shows in the most of the case, the degradation of the N-type module is within 5%. So in order to make sure that the large size module can adapt to outdoor installation as well as different climate conditions, so relevant measurements should be conducted ahead of actual application scenarios. For instance, the mechanical load test is to determine the largest load that the module can withstand. Non-uniform slow load test can be applied for PV module in the area of the heavy snowfall. And the wind tunnel test and hail impact test are evaluated whether the module can be adapted to windy weather and the hailing weather. And for the packaging and the transportation for large size, performance test of the rending vibration and the various shock testing include color parts on the complete packaging system of a module, simulate road transportation and the related mechanical impact on shipping units. Usually, truck transportation is very common and is considered to be the most severe methods of long-term transportation for shipping goods. In the right picture, we can see the module, the breakage of the pallet happened after the transportation test. And another picture shows that our engineer just took the picture on site, found that some packaging pallets and the belts has been broken. So sometimes maybe you can't find a breakage of the front side of the whole modules, but however, the micro crack may exist in solar cell inside. Even the initial power value without degradation, but after some years, big degradation will be happened in your PV power plant. So for larger size module, the pallet and the packaging method is highly recommended to be strengthened. And the here electrical parameter comparison for three typical dimension cells or module, we can find that the value of ISC increased to a larger extent with increase in the size of the solar cell. In addition, in consideration of the bifacial module, the current and the voltage under BSI condition may climb to an even larger value, so we need to care more about the electrical safety. So here, just one example of the bypass diode testing, thermal cycling test, reverse current overload testing. For the conventional module and the larger size module, we can see the test conditions are much stricter for the larger size of PV module. So when the module applied in the high temperature environment, such as desert climate or installed conditions that the module is difficult to heat dissipation, so the higher current carrying capacity is required for the bypass diode, especially in larger module. So this example just is for the guideline for the manufacturer to choose the qualifier supplier. Here is some failure case to share with you. The left picture shows one bypass diode is short circuit after the bypass diode testing. Middle picture shows junction box melted after the reverse current load test. The right picture shows the connector melted well after thermal cycling and the reverse current overload test. Also, the hot pot test temperature. As we know, the size of the module are becoming larger. Hotspot effect is rising to be a big concern in the PV utilization. In our lab, we found that even the PV module are of the same size, the hotspot temperature can still vary from the certain range. The reason can be attributed to the variance of cell technology in different manufacturers. Even though larger solar cell may cause high hotspot temperature theoretically, the cell process technology and the slice technology may practically play an important role. All about a result just come from a lab. But in order to take a comprehensive view of high efficiency PV module, we also set up the outdoor yield test. This is also one example, outdoor test based in Yinchuan, northwest of China. This is typical xerismic climate with abundant sunlight. Also, solar spectrum is highly consistent with AM 1.5. We compare the PERC module with N-type module. The results show that N-type module performs better power generation. Based on these results, we believe better temperature coefficiency and the low irradiating performance of N-type module contribute a lot to the total generation. Also, N-type module generate more power in the condition of the higher temperature. We can see in the left picture. Also, the low light intensity at the early morning and the dusk time of day, we also can see from the right picture. That means the N-type module has a better low irradiating performance. So this result is come from our outdoor performance base. It's a sense we found in our laboratory testing. So fourth, with our conclusion, LCOE is becoming the most important critical fact of global PV projects. Also, N-type module with large size is more promising to be an emerging technology. Risk come along with the benefits of the high efficiency module. Also, it's a challenge for manufacturer and third-party certification to fully evaluate the product characteristic and reliability. From our outdoor yield-based performance shows the power generation advantage of N-type modules. So last, I want to give you a very brief introduction of the TIFNOT. TIFNOT is the world leading third party focused on TICCET market with 153 years history. In renewable energy area, we offer testing, inspection, certification for manufacturer, for investor, supplier, EPC, and the owner of the PV components, PV module, and the PV power plant. Every year, we issue more than 3,000 certificates, offer around 23 international countries, accessibility for PV manufacturer. Until today, we have finished the performance evaluation for more than 60 gigawatt PV power plant all over the world. So that's all. Thank you for your attention.
Thank you very much for that, Roger, and to everyone who's spoken today. They're really, really interesting presentations. We've now reached a section where we can take audience questions. Just a quick reminder to everyone, you can submit those questions using the question tab on your screen. I have a couple of questions before some start coming in from the audience, or we've already got some, but quickly, Roger, just to pick up on what you said, you were talking about enhancing the mechanical properties of larger size modules. In that context, which part of the component is best or most recommended to be strengthened?
Yeah, sure. Yes, mechanical load test is very critical, and more people will care about this. Usually, for mechanical properties, we should really focus on the frame part, including the frame materials, metal or polymer, and the thickness, also the position and the number of mounting hole, as well as the installation methods. And the actually, some manufacturer also would like to take a set of the experience of increasing the mechanical load value gradually to determine the larger the mechanical load value that the module can withstand. So in our client, we also found produce the flexible PV module. They could choose a suitable base to support the module when we perform the mechanical load test or heel impactor test. So the suitable mounting method is highly recommended to make the deep considerations when you choose the mechanical test value and the also from the outdoor installation aspect, we also need to pay attention to the bracket, such as strength and the structure as well. Thank you.
Okay, brilliant. Thank you for that, Roger. So I've got a question for Halil, which is, what are your expectations regarding the market share of shingled modules moving forwards?
I think that by next years it will be growing because shingle module production equipment was not very common in the market. And as I see with Tongwei big capacity going into the market, there will be more shingles as well. By 2025, like next 3 years, I think that it will be more than 25% of the market. Okay,
well, that's great. Thanks for that answer, Halil. I've also got another question coming in for you, which is, considering shingle modules do have 2 bypass diodes, do you think it may cause any disadvantage at the marketing or the investment level? Halil, that was for you, and you're muted at the moment in case you didn't know.
Actually, I think that it's not that much of a problem because, as you saw already in the presentation, the high performance of the shingle modules under shading are so good that one more or less bypass diode will not affect the output as much as in the standard modules. So here we have advantages that is covering this point. So I don't think that will be a disadvantage.
Okay, brilliant. Thank you for that. Gang, just for my own benefit, I was just wondering, does Tongwei shingled module technology fringe any patents that are out at the moment?
A short answer is no. The shingle module concept was proposed, long time ago, 1956, I believe, and the patent was filed that year and granted, short afterwards. So, counting the years, has long expired. So that's for the, concept part. So right now, existing or active pattern on shingle module is really, how the cells design, how the process is done. So when Tongwei developed our unique module design process, we have been very careful about that. So no, our product does not infringe on any active patterns.
Okay, thank you for that. And how have they been doing in the field? I mean, how have they been performing? Have you got any data on that you could share with us, please?
Sure. We've been working on the shingle module for 5-6 years now. So obviously, in R&D, we've been very careful about to evaluate the structure and so forth. Then we, have the prototype we put in the field. So I would say more than 4 years, we've been putting our modules in the field, in the project, first, in a project owned by Tongwei, and later, by our customers. So for the, 4 or 5 years of experience, with large installations, projects by Tongwei and our customers, we have received very positive feedback. So the modules performs well, especially we mentioned about the benefit of the shingle module when there's shading or there's harsh environment. Our module actually performed very well.
Okay, thank you for that insight, gang.
Thank you,
this is one I think you should probably take on as well that's come in. So where does Tongwei fall on the 182 versus 210 millimeter wafer debate? So I think that's probably best for you, gang.
Yeah, okay. We're not on the sales side, but I'll try my best. So that's literally a billion-dollar question, isn't it? So the debate, for folks that's not familiar with this, is really referring to right now a few producers is producing 182 millimeters, and a few producers focusing on 210 millimeter solar cells. Obviously, Tongwei does do solar cells. We're the number one annual capacity wise in the world for solar cell. So the reasoning behind 182 and 210, my understanding is really related to how to optimize the full value chain. For example, when we build module with 182 millimeter, the idea is the width of the module will still be able to allow us to stack two pallets together and fit into a 40 inches container so it can be shipped around the world. So that's at least one of the major reason behind that. For the 210, I believe is besides it's 80% larger than a 156 millimeters, so economy of scale. It's also related to how big the diameter of the crystal puller is and how can producer to fully utilize that. So I guess both 182 and 210 has its sound reasoning behind that, but I don't think any of this is fundamental. So I guess as technology continue to evolve, I don't know, in the future, they might end up with another size for a period of time. But from Tongwei's point of view, we don't pick size. Actually, Tongwei are producing both 182 millimeter and 210 millimeter. In the future, whatever size is more suitable and to better serve our customers.
Brilliant. Thank you very much for that
Thank
insight.
You,
and yeah, I'm sure everyone will be keeping a close eye on what you're doing in that space.
Okay.
Guys, I think unfortunately that's all we have time for today. So this is a little reminder to everyone watching or listening that this will be available on demand shortly. Thank you again to all of our speakers. It's been very interesting, and indeed the audience for your attention. The next PV Tech Talk webinar will be on the 26th of October, and we'll release more details of that shortly. But thanks again to everyone, and we hope to see you next time.